cis 7 pi by 4 is nothing but cis minus pi by 4. 315 degrees is locating like this. Now in other way you locate like that, minus pi by 4. Next. So based on that u is given how to find v is given how to find u of the analytic function. I am going to do one problem. Similarly I am giving one more problem to you along with answer. You try it. One. 2011 for an analytic function f of z is equal to u plus iv comma u is equal to 3x square minus 3y square full stop. The expression for v considering k to be a constant is dash. Solution. U is given 3x square minus 3y square. Okay. Since dv is equal to dou v by dou x dx plus dou v by dou y into dy. Using CR equations, because we are going to find v, change these terms into CR equations with the help of CR equations. Minus dou u by dou y into dx plus this is dou u by dou x into dy. Equation 1, what I explained already, this one, by CR, Cauchy-Riemann equations. What is minus dou u by dou y, which is given 6y times dx. What is dou u by dou x? 6x into dy. Again this also you can take equation 1. It is in the form of m into dx, n into dy. I told you in the previous discussion, I will verify this is exact or not. See, what is dou m by dou y? 6. Dou n by dou x? 6. Dou m by dou y is equal to dou n by dou x. Look at the procedure of exact differential equations which we have discussed in differential equations chapter. Okay. Integrating. Okay. I can write here is exact. Okay. Integrating, we get left side derivative d cancelled after integrating, which gives v. Right side integral m dx, that is 6y dx, keeping y terms constant plus terms in n not containing x. There is only one term 6x which contain x, leave the term and then add k, because I gave the procedure after integrating I add the c constant. Here it is mentioned in the question considering k to be a constant. That means after integrating you should add k instead of c. So 6y constant integrating with respect to x becomes 6xy plus k. So for this u and v you can check again CR equations satisfied or not. Then only this V is correct. And for every analytic function, real part U, imaginary part V satisfies Laplace's equation. For every problem you can check. Okay. Both U and V, real and imaginary parts of an analytic function f of z is equal to U plus psi y, both satisfy CR equations as well as Laplace's equation. In the same procedure, I am giving you one more problem, later you do. (2010) If f of x plus iy is equal to x cube minus 3xy square plus I times psi of x comma y and f of x plus iy is analytic function, then psi of x comma y is, I will give the hint for this problem. Answer: psi of x comma y is equal to 3x square y minus y cube plus k, or you can add c also. K is any integration constant, maybe 0 or non-zero. Just only the notation, instead of f of z, z is nothing but x plus iy. Here u, this is v, v is denoted by psi function, u is denoted by phi function, like that. Okay. Hint. Here u of x comma y, or this is also denoted by phi of x comma y, is equal to x cube minus 3x y square. Then v of x comma y, our original notation, here it is mentioned psi of x comma y is equal to question mark. This is the answer. Just write hint. R. And f of z, these are the notations, or f of x plus iy. Okay. Or w, these are the notations for the given f of z. And this x plus iy, sometimes it is also denoted by 2D representation x comma y, just like 3D representation in vectors a1, a2, a3, here also like that, depending on the way of expressing the question, u, v, phi, psi, like that. For analytic function fz is equal to u plus iv, comma v is equal to e power x sin y. Find the not like this, or that is the expression for u here, because v is given, considering the expression for u comma considering, okay, C to be a constant, comma is. Answer u is equal to e power x cos. These two problems based on method 1. Now I am going to method 2. Here u is given, v is given, you need to find u. That is second case of method 1. Method 2. The name of this method is Milne-Thomson method. In this method, comma, we get f of z in terms of z, comma, irrespective of whether u of x comma y real part or v of x comma y. Be given. In the previous problem, if u is given, then we got v and then substitute these u and v after obtained in the given function f of z is equal to u plus I v given in terms of x and y. But in this problem, directly in terms of z only it is giving. Case A. If real part u of x comma y be given, then take f dash z is equal to, because we are u is given, dou u by dou x minus I dou u by dou y. Very, very important. This formula you have to consider. F dash z, dou u by dou x minus I dou u by dou y whenever u is given. Replacing in the next step, replacing x by z and y by 0. And then integrating with respect to z, comma, we get f of z in terms of z. So just remember this formula, or basic formula, it is sufficient to remember. What is basic formula for f dash z? dou u by dou x plus I dou v by dou x. Because here u is given, take the CR equations, then that f dash z becomes here. Because u is given, I expressed both derivatives in terms of u. After that, x is replaced by, put x is equal to z and y is equal to 0. You will be getting completely in terms of z. To remove that derivative dash, we should integrate, which gives f of z, the right side, directly in terms of z. Replacing x by z. Case B. If v of x comma y be given, then take f dash z. Because v is given, just search the f dash z formula, both are containing v. Dou v by dou y plus I times dou v by dou x. Not required to by heart in this method the both f dash z formula, but it is sufficient to remember f dash z original formula dou u by dou x plus I dou v by dou x. Then with the help of CR equations we will get both cases. And same as above. And copy this, replacing x by z and y by 0, then by integrating with f of z in terms of z. Same. Coming. Similarly, in this case, one example I am going to do, other example you do later. Just write what I gave the last two sentences in case A here also, all of you. Replacing x by z and y by 0, and then integrating with respect to z, we get f of z in terms of z. See here, after getting f of z, then separate again real and imaginary parts. After taking z is equal to x plus iy, simplifying, you will get u and v, and check whatever the things obtained u or v with the given u or v. If it is matched, then only your f of z is correct, otherwise it is your mistake. Suppose u is equal to x square is given. After applying this method, suppose if you get f of z is equal to some z square, then write z square or z 1 by z, that is in terms of x and y, that is because z is equal to x plus iy. Simplify, separate real and imaginary parts. Real part is u. If your u, that is given x square, is coincident with, after separating into real and imaginary parts, that real part, then only your f of z is correct, otherwise it is wrong. From the given u and from this f of z, after separating into x and y terms, taking z is equal to x plus iy, separate, that obtained u is coincident with given u, then only your f of z is correct, otherwise it is your mistake. One. This is given 2008, 2 marks. An analytic function w of z, that is instead of f of z it is given w of z, is defined as W is equal to u plus iv, where I is equal to root minus 1, and z is equal to x plus iy, full stop. If the real part is given by u is equal to y by x square plus y square, comma, w of z is dash. Solution. U is equal to, first find for the given u both partial derivatives, implies dou u by dou x partially with respect to x, keeping y constant, this derivative becomes minus 2xy by x square plus y square whole square. Just applying u by v rule, keeping y as constant, quotient rule, and dou u by dou y with respect to y, u by v rule, which simplifies to x square minus y square divided by x square plus y square whole square. Later you find the derivative and check these two are correct or not. Next, we have f dash z. This is also denoted by dw by dz is equal to, because u is given in terms of u, both terms in terms of u, in f dash z formula what I gave for representation, minus I dou u by dou y. Simplify here, substitute here, dou u by dou x becomes minus 2xy by x square plus y square whole square minus I times dou u by dou y, x square minus y square by, and what I gave the procedure, let x tends to z and y tends to 0, that is replace x by z and y by 0, comma, we get f dash z is equal to, this is 0, minus I minus plus z square by z power 4. So this simplifies to minus I by z square. Integrating, comma, we get left side f of z, 1 over z square integration is minus 1 over z, so I by z plus c. Your f of z is nothing but w of z, so just substitute here z is equal to x plus y. For verification I am telling, and conjugate the denominator and separate real and imaginary parts. Check the given real part is with here obtained real part equal or not, otherwise this is wrong. F of z value what we found or what we calculated, that is wrong. Okay, substitute here for verification I am telling, put the verification, substitute z is equal to x plus iy, conjugate the denominator and then simplify, separate real part, imaginary part. That real part obtained is coincident with given real part, then only this correct all the steps, otherwise we have done some mistake. Second one, if v is equal to e power x sin y, comma, then find the analytic function f of z is equal to u plus iv in terms of z. Okay, answer f of z is equal to e power z. This is the answer, exponential z. Just substitute x plus iy here, separate this imaginary part coincident with here, as above, case B. Okay, this is e power z. And remember one important point, whenever f of z is equal to u plus iv is analytic, real part represents some family of curves, imaginary part represents another family of curves after taking both u and v is equal to some constant, then both are intersecting orthogonally to each other. That is, u is equal to some constant is an orthogonal trajectory of v is equal to another constant, and vice versa. U is real part, v is imaginary part. Real part u is equal to some constant represents one family of curves. Imaginary part v is equal to another constant represents another family of curves. Both family of curves form an orthogonal system. This is, one is intersecting orthogonally at an angle of 90 degrees. Okay. Whenever f of z is equal to u plus iv is analytic. Please remember that point. Sometimes one more questions like that. Next, complex line integral. The line integral of f of z along a path or curve C is obtained by integral over C f of z dz, and this is expressed as two real line integrals. Integral over C f of z is u plus iv, dz is dx plus I dy. Multiply these two complex numbers, separate real and imaginary parts, u into dx, the terms do not containing I, first collect, I into I square value minus 1, that is minus v into dy. This is one real line integral, plus in other two terms I is getting common, keep outside I, and integral C v into dx plus u into dy. This into this and this into this, both are having I common, keep outside this. So this is a real integral and this is a real one. Finally it is a complex line integral. Since z is equal to x plus iy, f of z is equal to u plus iv, implies dz is equal to differentiation of z is dx plus I dy. This is the reason. If C is a closed curve, comma, this line integral is denoted by integral over C, just vector treatment, here complex treatment. Vector line integral have given, here now complex line integral, f of z dz. So this integration depends on the path. Yesterday I have given line integral problems depends on the path C. Okay. Whenever f of z is analytic, then this line integral is independent of the path joining. Yesterday, instead of here the sentence analytic, yesterday I gave in vector line integral chapter, f bar is irrotational, curl f bar is equal to 0, but that line integral is independent of the path. That is, without path we got the integration answer, the line integral answer. I have done first problem of yesterday's class, line integral. Here also, whenever f of z is analytic, not required to path, you will get the answer. If f of z is analytic, then integral over C f of z dz is independent of the path joining P1 and P2.